So this lesson we're doing 2.2 conditional statements. I would recommend writing all of these vocab words. Everything that I write down or that I put on the slide, I want you to be writing down because this is going to be a lot of vocab in this lesson. Okay, so a conditional statement is an if-then statement. So you use this a lot in biology. So the way that we're going to write it is we're going to have P and then we're going to have that arrow right there. Okay, so if P, then Q happens. A hypothesis is the part P which is following if. Okay, so this is my hypothesis right here. Kind of like in biology, you start with your hypothesis and end in your conclusion. So if this, then we say my conclusion. So if is my hypothesis and then is my conclusion. So you conclude with it. Okay, so here's an example. If an angle measures 90 degrees, then it is a right angle. Okay, so in this situation, my hypothesis, I'm going to highlight it. If I can get my highlighter. Okay, so my hypothesis is that red, which I accidentally just crossed out, and then my conclusion then is what's after in the blue. Okay, in negation, the opposite of the statement P, not P. Okay, so when we're talking about negating something, we're trying to find the opposite. The truth value of a condition is either true or false, so it can be made true or false. It can be either one. So to show a conditional is true, show that every time the hypothesis is true, the conclusion is also true. So if an angle measures 34 degrees, then it is acute, okay? So we're trying to show that the conditional is true by saying that the hypothesis is true and the conclusion is true. So both of those things have to be true together. To show a conditional is false, you find only one counterexample. So if a month has 28 days, then that month is February. Okay, because there are also different months that are also February. So you only need to find one that counteracts it being false. Conditional. So if an animal is a dog, then it is a mammal. So converse, you exchange a hypothesis and the conclusion. So we're switching P and Q. If Q, then P. Okay, so we're just switching what our hypothesis and our conclusion were. So if, in this situation, if an animal is a mammal, then it is a dog. So we just flip-flopped them. The inverse, we negate both the hypothesis and the conclusion of the conditional. Okay, so that means we are proving that the hypothesis and the conclusion are both wrong. So this is what the sign looks like. The negate sign is the little squiggly. So if not P, then not Q. So if an animal is not a dog, then it is not a mammal. Contrapositive. We negate both the hypothesis and the conclusion of the converse, okay? So a converse, again, is when you exchange the hypothesis and the conclusion. So we're going to flip-flop our hypothesis and our conclusion, and then we're going to negate both of them. So prove that they're both wrong. So we're going to flip them, and then we have the little negate sign, so that's that little squiggly. So if not Q, then not P. So if an animal is not a mammal, then it is not a dog. Equivalent statements have the same truth value. Okay, conditional and its contrapositive are equivalent statements. Okay, and the converse and inverse of a statement are also equivalent statements. So if I'm taking geometry, then I'm taking a math class. Converse, if I'm taking a math class, then I'm taking geometry. That is false. Inverse, if I am not taking geometry, then I am not taking math class. Okay, that's also false. So it's like this example right here. The converse and inverse of a statement are equivalent statements. These were both false. Contrapositive. If I'm not taking a math class, then I am not taking geometry. Okay, that's true. Oops. So in this situation, we're going to do like this, and we compare it to our conditional, so our original, okay? And they're both true. So you can see that they're both true, which means that they're both equivalent statements.